Hello everyone. In this video we're going to be solving a very interesting problem. We have alpha cubed minus 3 alpha squared plus 5 alpha is equal to 17 and beta cubed minus 3 beta squared plus 5 beta is equal to negative 11. And we're supposed to find the value of alpha plus beta based on these equations. So where is this problem from? This problem is actually from the Irish Mathematical Olympiad. So if you're from Ireland, say hi in the comment section down below. Great, let's go ahead and proceed with the solution to this problem. I'll be presenting more than one method. Obviously, one of the methods is going to be better than the other one. And you're going to tell me which one you like better. Okay? All right, let's start with the first method. So for my first method, let me rewrite the equations. Alpha cubed minus 3 alpha squared plus 5 alpha is equal to 17. And then beta cubed minus 3 beta squared plus 5 beta is equal to negative 11. Now, this problem has an interesting story for me because I've seen this problem many years ago. But at the time, I was just a college graduate, I think, or about to graduate. And I'm like, what the heck is this problem? You know, it doesn't make sense at all. But anyways, this makes more sense now. So we're supposed to find alpha plus beta from here. And first method is basically going to be depending upon finding the value of alpha and beta, because why not, right? How would you find alpha plus beta if you do not know what they are? So how do we solve a problem like this? Let's say take the first equation. The second one is kind of similar. So let's go ahead and rewrite this equation. I can leave the 17 on the right-hand side. That's okay. This is a cubic equation, and there are methods for solving cubics, right? There's more than one. And one of them is known as the cubic formula. Some Italian guy found it and someone else stole it from him, so on and so forth. There's a lot of stories about it which you can read about. But if you search for Cardano and the cubic equation, you'll find a lot of good stuff. So to solve this problem, we can actually do this. Get rid of alpha squared and use a different variable. So the new equation that we come up with is not going to have quadratic term. And there's a really nice identity that I always use. You should be familiar if you've seen my channel before, if you've been following for a while. If you haven't, keep an eye on it. I also have another channel called aplusbi, which focuses on complex numbers. By the way, the new schedule is publishing one video per week on that channel, so that it's not too much. Come on, you can probably watch a 10-minute video every week, right? All right, let's give it a support. Now, the cubic formula works like this. So I'm going to replace alpha with something. Which variable should I use? Maybe it doesn't have to be a Greek letter, by the way. I can use y. Let's just say I use alpha equals y plus something. So when I plug it in, the y squared is going to disappear. To achieve that, here's what you need to think about. What's the coefficient of alpha squared? Negative 3. What's the degree of this polynomial? 3. Divide this by that, okay? And then negate the answer. Makes sense? That's going to give you the number you need to add. In this case, we're talking about negative 3 divided by 3. And if you negate it, you're going to get a positive 1 from here. So in other words, if you replace alpha with y plus 1, y squared is going to disappear. Let me show you how this works. Replace alpha with y plus 1. Oops, the other one is supposed to be a cube. And then plus 5 times alpha, which is y plus 1, is equal to 17. Now, if you expand this, y cubed plus 3y squared plus 3y plus 1, that comes from here, the binomial theorem. And notice that this is y squared plus 2y plus 1, but go ahead and distribute to negative 3, negative 3y squared, negative 6y minus 3, and then plus 5y plus 5 is equal to 17. Notice that y squared cancels out. That is the goal, okay? We want to get rid of that, and I'll tell you why this works. Y is a different y here. So we have 8y minus 6y is a 2y, and then we have the 1 plus 5, 6. 6 minus 3 is a 3, and then I want to subtract the 3 from the 17, and that should give me 14. Now, this equation is called a depressed cubic equation because we got rid of the y squared. It's really nice because now we have this identity, a plus b cubed minus 3ab, a plus b equals a cubed plus b. You probably know this, right? Hopefully you're familiar with this formula, because if you go ahead and factor an a plus b here, you get this formula for the sum of two cubes, so on and so forth. A lot of good things come out of this. Now, here's what we're going to do. We're going to go ahead and set the a plus b equal to y. In other words, if you have an equation like this, then we know that a plus b is one of the solutions, which is good because that's exactly what we have. If you make the coefficients work, take a look. This means that negative 3ab is equal to 2, which means ab is equal to negative 2/3, and a cubed plus b cubed is equal to the constant, which is 14. Now, this may look like a cubic system, but it's actually quadratic. You know why? Because if you cube both sides here, that'll give you negative 8/27. Be careful, because if you cube a negative number, you get a negative number. And then from here, I can isolate b cubed and write it as 14 minus a cubed. And then this can actually be substituted here, right? That gives us a cubed times 14 minus a cubed. And you kind of formulate this, and you don't have to go through all these steps, but this kind of allows me to kind of process the solution, and also I don't have to memorize the formula. That's the good thing about it. The only identity you need to know is this one, and that shouldn't be too hard to come up with, even if you forget. Okay? Awesome. Now, this is equal to negative 8/27. So what's going to end up happening is you're going to get a cubed and a to the 6th power. If you set a cubed equal to c, that's going to give you a quadratic in c. That's why I said this is a quadratic system, not a cubic system. So by solving for c and then cube rooting it, of course, there's going to be two solutions. That should be, right? By cube rooting it, you're going to get the values of a and b. By adding them, you're going to get the y. And then by back substituting, you're going to get the alpha. Good luck with that, right? That's going to take forever. But let me tell you, I can actually give you the solution. By the way, these cubics each have one real solution and two complex solutions. That they come in complex conjugates. Are we interested in complex solutions? I don't think so. The problem, I can't remember. Okay, sorry, I forgot to say that. It does state the real numbers alpha and beta. So we're not interested in complex solutions. So if you can find the real solution from here, that would be actually really good. But sometimes you don't, so you kind of have to work with it. Make sense? To keep a long story short, you can go through the process. But for alpha, I get something like 3.1349. And for beta, you're going to find something similar. And then go ahead and put these together. And beta is going to be negative 1.1349. And guess what alpha plus beta is going to look like? It's going to be 2, right? Exactly 2? We'll see, because that's what the second method is hiding. Okay, so let's go ahead and take a look at the second method real quick, because I think this is, in my opinion, this is like a more elegant solution. Because imagine you're taking this contest, okay? And again, if you're from Ireland, let us know. And let's say you're taking the contest and you need to solve the problem. You don't want to use the cubic formula because you only have limited amount of time. And by the way, this problem was in 1993. Okay, so anyways. So let's see. What are we going to do? We're going to go ahead and, okay, I'm going to rewrite the problem. This is 17. Okay, now here's what we're going to do. We're going to go ahead and define a function, which makes a lot of sense, because if you look at the left-hand side of both of these equations, don't you see a pattern? Yes, the answer should be yes. So we're going to define f of x to be x cubed minus 3x squared plus 5x. Okay, now how does this help? Well, this gives us two pieces of information that is valuable. First, this gives us f of alpha is equal to 17, because if you plug in alpha into this equation, into this function, you get the right-hand side, I mean the left-hand side here. It should be the left-hand side. And if you plug in beta, you get this equation right here, and that is equal to negative 11. So it's like, you're probably asking like, what is so good about this, right? Well, let's go ahead and add these up, and you might be questioning, hey, why are we adding them? because we're going to try to find a pattern. So we know that f of alpha plus f of beta is 6. The question is then, can you find alpha plus beta from here? That's what this problem is basically asking for, okay? That's what we're going to try to do. And here's how we're going to do it. This is going to be a very interesting way to do it. I don't know whoever came up with this problem. I think they did a really, really good job. And if you know of any similar problems like this one, please let me know. I'm always looking for interesting problems. You can always suggest them in the comment section. I also have a form, which I barely look at, so it's probably better if you just suggest in the comment section. And definitely, yes, I do take suggestions from my beautiful viewers. Okay? You guys are amazing. So keep up the good work. Now, let's go ahead and see how we can use this information to find alpha plus beta, okay? All right. Now, we're going to take this expression, like f of alpha, right? And try to do something out of this. Let's start with this maybe. Alpha cubed minus 3 alpha squared plus 5 alpha. And then we can go ahead and bring down the, I think 17 from it. But let's just go ahead and leave it like this for now. I'm going to leave it like this. And similarly, we're going to do the same thing with beta. But let's just do this for alpha first. So here's what we're going to do. Notice that this is kind of similar to the cube of an expression, right? Isn't it? Yeah, so here's what we're going to do. We're going to write this as follows. If I write it this way, it's going to start looking like this, right? Isn't it? So, but I can just add 3 alpha because I have 5 alpha, so I kind of need to make up with 2 alpha. Okay, make sense? Okay, great. Now, but for this one, I do need more terms, right? So let's go ahead and do this. I need to make 3 alpha and then minus 1. So what did I do? I just added 3 alpha minus 1 to the equation. So now I need to subtract it. In other words, I need to add negative 3 alpha. So I have 5 alpha, negative 3 alpha plus 1. I need to do it on the left-hand side. Not on both sides, because I already did that here, and then I undo it. Okay, here's the cool part about this. This gives you alpha minus 1 to the 3rd power, and then this gives you 2 alpha plus 1 equals 17. Now, you can still leave the 1 and the 17 together, or subtract 1. It's totally up to you. Let's do that. Subtract 1, and you'll get 16. Okay, so far so good? Now, here's what I want to do. I want to continue with the pattern. Now, I want my new variable to be alpha minus 1 instead of alpha. You got that? So I'm going to subtract 2 from both sides. And that'll give me 14. Good. Everything works out. And then I'm going to go ahead and write this as follows. You got that? So far, so good? Awesome. Now, this expression is equal to 14. But if you go back to the original one, it's supposed to equal 17, right? So what is that supposed to mean? Well, this is, what I can do is I can add 3 to both sides. Let's do that. I think that'll be the safest path. Add 3 to both sides and you'll get 17. And now notice that 17 is f of alpha. Beautiful. So now this is f of alpha, right? Great. So now we do know that this expression is equal to 17. Wait a minute, is that f of alpha? Yes, of course. But then I only need this part. So let's go ahead and subtract 3 from both sides. In other words, sorry if I made it too confusing. That's what I usually do. I'm going to go ahead and subtract 3. And now this expression is going to equal f of alpha minus 3. I meant 3, not 4. Okay. Make sense? So the expression that I got here, which was 14, right? I don't want any constants here, by the way. I'll show you why in a little bit. This is 3 less than f of alpha. Makes sense? Because f of alpha is 17. Great. Now, similarly, you can do the same thing for f of beta. And let me tell you, f of beta is equal to beta cubed minus 3 beta squared plus 5 beta. And now after working this out a little bit, you should get something like this. Beta minus 1 cubed plus 2 times beta minus 1, just like alpha. But then you're going to have an additional 3 here. And this is the beautiful part. the most beautiful part, because they both have the same leftover. So now this expression, and I'm going to erase this so that we can work with these two equations. Beta minus 1 cubed plus 2 times beta minus 1 is equal to f of beta minus 3. This is the best part, because now this allows us, let me go ahead and erase this for you. And we can kind of even bring these together, like bring them closer. Okay, here we go. And guess what? We can now go ahead and add these two equations. Beautiful, right? Oops. So let's go ahead and add them up. And when we add them, this is gonna be interesting. A lot of terms, right? This plus this. Okay. And on the right-hand side, I'll probably have to move this again because I don't have any room. Oops, I hope this works. Oopsies, we lost the 3. Let's go ahead and bring it all back. Okay, where does that go? Here. All right. And this is equal to f of alpha from here. Notice we're adding these two things. Plus f of beta minus 6. Beautiful. You know why this is beautiful? Because f of alpha plus f of beta, if you remember, is equal to 6. Nice. Now we can go ahead and plug it in here. And guess what? That's going to give you 0. Beautiful. Let's go ahead and erase this so we don't have to rewrite this gigantic thing. And now we're going to go ahead and work on this equation. Beautiful, right? Now, what is really cool about it is that we can go ahead and pair these up, because this is sum of 2 cubes. And these two can also hopefully work with us, right? Okay, let's see how this works. First of all, we can definitely factor out a 2 here. But let's do the cubes. If you remember, x cubed plus y cubed is equal to x plus y. That's one of the factors, right? And then the other one is going to be x squared, right? Plus xy plus y squared. Okay. And then plus these two things. But again, we're factoring out to 2. So that gives us alpha plus beta minus 2. Beautiful, because it's the same as this one. Take a look. This one and this one, they're equal. Beautiful. And the whole thing is equal to 0. Sorry, there's not enough room. So now we have the following. Alpha plus beta minus 2. That's a common, oops. I don't know why this jumps sometimes. This is a common factor. And then the other factor is going to look like this. Alpha minus 1 squared plus alpha minus 1 times beta minus 1 plus beta minus 1 squared plus 2. And the whole thing is equal to 0. Now, what's really, really cool about it is that the second factor, you got to know this. If this is, oops, how did I make that hocus pocus? If this is equal to x, let's say, and this is equal to y, you're basically looking at x squared plus xy plus y squared plus 2. And one thing you should know, in factoring sum or difference of 2 cubes, one of the factors gives you a nice solution, the other one doesn't, because it's always positive. Let me show you why. If you go ahead and write this as follows, this is really, really cool. I don't know, this just makes me excited. This is x plus half of y squared, and this is 3y squared over 4 plus 2. Notice that this is a non-negative quantity, and this is a positive quantity. So this expression is always greater than 0, which means this can never be 0, which means this has to be 0. As a conclusion, because alpha plus beta minus 2 is equal to 0, alpha plus beta is equal to 2. And that's what we were looking for. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out SyberMath, the Shorts channel, and aplusbi. And bye-bye.